Oh boy, I went this whole time without sound. I did so much there. That's ridiculous. Thank you. I appreciate the heads up. Uh, that could have been terrible. Thank you for letting me know. Whoops. Whoopsies. So, well, I guess I wasn't able to explain any of this. So you have your trinomial, your quadratic equation. There are three terms in it. That's why you use the word tri. So this is your trinomial. Trinomial. Okay? So we have our three terms all inside of our trinomial. And what I was saying earlier when you guys weren't able to hear me is, first off, I appreciate every last one of you. I've gotten about 25 subscribers just in the last like 2 days. So that's really cool. Appreciate it. And by you guys participating, by you guys subscribing, you're spreading this channel, right? So I can help more people with math, which that is great. That is perfect. If you are hanging out in the chat, I appreciate you. Thank you for letting me know that my sound wasn't on. That really helps me out, especially since I did that entire intro without sound. So what we've done is we've factored a trinomial. We've factored it down into a binomial. This is also your quadratic. This is a quadratic equation. And if you remember, a quadratic equation is anything that's in the form of, we'll do it in yellow. Our quadratic equation in yellow. A quadratic equation is anything in the form of y equals ax squared plus bx plus c, where a does not equal 0, right? So that is a quadratic equation. Cool. I appreciate you guys hanging out. Like I've said, pretty cool. And how do we go about solving this? How do we do at this point? Well, this is we set this equal to 0 to find where this equation crosses your x-axis, right? And oh, I don't have my music playing today either. I'm just not prepared. I do have a Red Bull just to help me get my wings going, right? Ooh, okay. But what you do is you set this equal to 0, because when you think of the ordered pair, let me write that out. When you think of the ordered pair of, and your ordered pair is going to be, let's just say anything, x, we'll put a little question mark there, and then 0, what happens? Where are you? Where are you located at on your graph when your y is 0? If we were to graph this, so straight enough line. My horizontal line is nice and straight. So if your y value is 0, where are you at on your x? Well, like, where are you at on your graph, right? Well, if your y value is 0, then you're on the axis. You are here. You are maybe here or over there. You are on the axis, okay? You are hanging out on the x-axis. Remember that your horizontal line is your x-axis, your vertical line is your y-axis. So you're hanging out on that horizontal line. Why is that important? Because when you cross the x-axis, so let's just imagine this is our parabola. Okay, something like that. When you cross the x-axis, right at that point when you're crossing the x-axis, what is your y coordinate? How high up are you on the y? Well, you're at 0. So you set it equal to 0, and then you solve. So what we do is, like, you might ask why. Why are we taking these two terms and then we set them equal to 0? Well, what you do, the reason why is, so this whole equation here is equal to 0, right? And so when it's equal to 0, what does that mean? When you have two things being multiplied, you have a, let me go, a times b equals 0, right? So that means that either one of them is 0 or both of them are 0. So either a is 0, b is 0, or they're both 0. And because of that being true, it must be true, then what we can do is we set both of these equal to 0. So we set x minus 2 equal to 0. And actually, let's go ahead and we will erase a little bit bigger. There we go. We will erase that. And we will go x minus 2 equals 0. And then we will give ourselves just a little bit of space. So we have x plus 4 equals 0. Okay? And how do we solve these single-step equations? We solve these single-step equations by adding the 2 over the inverse operation. This 2 on the left side cancels out. And then you subtract the 4 here and subtract 4 there. The 4's cancel out, and what you are left with is x equals 2 and x equals negative 4. Right? I went a little bit fast through that. Let me just check something out here. I hope that my sound is back up and running very well. And as you can tell, I did do like my thumbnail is playing chess and doing math. So I figure why not? At some point, if we don't have a ton of people in here, I might hang out and do a little bit of chess, just because. And on that note, let's get a little bit of music going. Just a tiny bit. This is that copyright-free music. I'm not exactly sure what music I can play and I can't play, and I think I can turn this up just a little bit. There we go. Okay, so I hope you can hear me. Can you hear me okay? Let me know. Let me know. Oops. And there we go. Now I'm all set and ready. Make sure, like I said, if you're just swinging on, if you're passing through this live stream, I greatly appreciate any types of subscribes, likes, comments. You can say hello. It's always very, very nice. But let us go through and kind of get a better understanding of what's happening. We have our 2 points, so I'm going to erase everything on the right side here. I'm going to erase all of this. We don't need that anymore. And I'm going to do just a graph. At least have a little bit of a graph of this, okay? And, oh, there we go. So I'll draw my line down. And I think I am good as far as being on the screen. There we go. Oh, that actually looks okay today. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Get my coordinates all set up. So this is how I would always draw my graphs. I always draw them this way. And then what I do is I come back in and I say, okay, this is -5. This is +5, +5, and -5. And then we know that our horizontal line is your x-axis and your vertical line is your y-axis. So I've just drawn a fairly nice graph here. Not too bad. I mean, like the coordinates. And what I'll do is I'm going to plot these 2 points. I'm going to plot the x equals 2 and the x equals -4. And that should help us out a little bit. At least get a better understanding of what's happening. So we have x equals -4. And x equals +2. And then you ask yourself, okay, is a greater than, or what is a in this? Remember, if you have that form of ax² plus bx plus c, and your a is positive, that means that your parabola is opening upwards, right? So your parabola is opening up upwards. The other thing that we can do, and just to work through a little bit of it, let's go ahead and let's just graph a couple of points. So, and like I was saying earlier, if you're popping on in, just, you can comment, totally fine. Yeah, so I have almost a 2-minute delay, I think, which is not good. I need to not have a 2-minute delay. I need to adjust that really bad. Let's see. Maybe. Can I do it while I'm streaming? You know, I think what I will do... No, we'll just stay in the stream. Like, I'll have to deal with the latency one more day, and then I will remember not to set that anymore. Okay, so what we're going to do is we're going to graph some points. Whoa. So we are going to make our table, our XY table, and we're going to pick my favorite 3 points, just like always. So that is -1, 0, and +1. And when we plug that into this equation up here, what do we get? Okay, so -1, let me erase all of this stuff. We have our 2 points. Where is my eraser? Okay. Actually, I don't even need this anymore. This was mainly just to get these 2 points here. So we still have we have it written down, +2, -4. That's where our zeros are at. That is where we have our, where we will cross the x-axis. And the main reason why I'm deleting all of this is because I want to be able to rewrite our equation. So it's y equals, and then plug in the -1 squared plus 2 times the -1 minus 8. And we will work through this. We will simplify this equation. We've already plugged in everything, so we're just going to solve for the y. We're good to go. So -1 squared. What is -1 squared? That is another way of thinking of, it's a little bit dark, It's a -1 times a -1, and that is a +1, plus 2 times a -1, that is a -2, and then minus 8. Okay, so if we go through, and this is all y equals, and then if we go through and we just go left to right, so 1 plus a -2 is a -1 minus 8. -1 minus 8 is, what is -1 minus 8? That is a -9. And of course, all of this is y equals. So y equals a -9. And that's it. We're good. We're good with our first one. And then 0. When we have 0, so x squared is 0. 2 times x is 0. We're at a -8. When everything else, I did that all in my head. Because 0 times anything is 0. So 0 times itself is 0. 0 times 2 is 0. And then we're just left with the -8. So y equals -8. And then lastly, our 1. So with 1, we plug in 1, we get 1 squared. 1 times 2. Let's go back. I'll erase this stuff here. So let's plug in our +1 into our equation. And so we have 1 squared plus, and I think you guys can see all of this okay. I appreciate the heads up. Thank you. 1 squared plus 2 times 1 minus 8. And so 1 squared is 1. 1, and then 2 times 1 is 2 minus 8. And then same exact deal. Go through. So we get 3 minus 8. And that is -5. So -5. Okay. And we're starting to get a little bit of an idea here that, so if you think of it, at -1, so we can extend our graph out a little bit, and let's go ahead and do that. I will extend the graph just a small amount. Okay. Just so we have it a little bit, Now, just so we have it a little bit more clear of what's happening. I can erase that. There. So we're just graphing this problem. Ooh. I can make that a little bit, that line a little bit bigger. Okay. And I'm just extending this out probably to like 9. Okay. So we have, make sure you label it all. 1, 2, 3, 4, okay, 5. 1, 2, 3, 4, 5. So this is now -10. This is -10. 2, 3, 4, 5. So this is +10. 1, 2, 3, 4, 5. Put your arrows on there, on all of your axes. There we go. Got it looking nice and neat. Well, kind of neat. As neat as what I feel comfortable with right now. So, now let's graph this. Now that we have our graph kind of looking a little bit more, the ability to graph it is there. So -1 and -9, where would that be at? Well, so -1 is right there. I put a little dot on the graph, teeny tiny little dot, and then we want to go to -9, so we go down 9. And so that looks like it would be right about here. And then at 0, we are at -8. So it's right here. And at 1, we are at -5. Okay. And so I'm just going through and I'm plotting all of these points. And so technically, if I go to -2, I should be coming back up. That's one thing that I know by looking at this. So if we were to plug in -2 into our table and run this, let's do that. Let's see what that looks like. We should become closer to the positive area because your parabola is facing upwards, right? So let's plug in the -2, and what we get is y equals -2 squared plus 2 times the -2 minus 8. And let's go ahead, we'll get rid of this. I don't know why I still have that 0 there. And so what is -2 squared? What is -2 times -2? We now have a +4, so y equals a +4 plus, so 2 times a -2 is a -4 minus 8. But what is a 4 plus a -4? Those cancel out into a 0, so y equals -8. Okay. So now, if you look at it, we were at -9, but now at -2, we are at -8. Okay. And you can almost see it right here, right? Like our first point of -1, -9, that is pretty close to being the vertex of this parabola. That should be the vertex of this parabola, okay? Which is kind of nice. It's super, super nice. So let's go ahead and just kind of give this a light graphing here. Nothing too crazy. So it comes down, swings around. Oops. Oh, dang. So it comes down like that. There we go. Boom. We have successfully graphed our parabola. Not too difficult, right? I mean, it's you just take your points, you plot them, you're good to go. I think a lot of people will struggle more with the factoring of quadratics, or using the quadratic equation, which what I will do, since this is kind of like a free-for-all class today, I will look up some example questions. Highly recommend, if you ever need like worksheets and you're working independently, I would recommend that you take a look at quadratics, or not quadratics, look at Math Aids is the name of the website, and it is super nice, super, super nice for all of your worksheets. and just example problems. It randomly generates them, so you can keep doing them over and over. Let's take a look. We're gonna just solve some quadratics by factoring. Let's take a look at what our options are. What do we have? Oh, perfect. I think these will be some pretty good examples for us to work through. A little bit more challenging than what we're used to, so let's take a look. And we might need our quadratic formula too, okay? So let's go ahead and we will make sure we are all set. We are going to just solve some quadratic equations. We might need that quadratic formula, so we are going to get that down. So our quadratic formula is, let's erase everything. We graphed our first one. Okay. So our quadratic formula is, I'll label it. Oh, I moved. Oh no. Wait, I think there's an easier way. Let's see. We'll use the full paint can. That doesn't help any. And I'm on oh, I know what I can do. We can add a new layer. And then, bam, everything is gone. Perfect. Exactly what I wanted. So our quadratic formula. Okay. What is it? What is your quadratic formula? I don't have my chat up because I was moving windows around. Actually, did I close my window out? No. Okay. I'm still here. Good. Good. Okay. So our quadratic formula is the following. So it is x equals, and then negative b plus or minus the square root of b squared minus 4ac. And all of that is over 2a. Okay. So that, and then always remember that your form for your quadratics is y equals ax squared plus bx plus c, and then we'll put a little comma and say that a cannot, I'm almost off of the screen, a cannot equal what number? 0. Okay, so a cannot equal 0. So the formula is time consuming, and what I'll ask you is what you'll want to ask yourself when you're taking the test is you want to be time efficient, and sometimes factoring is the fastest. But if you see a quadratic and seems to be extra difficult, right? So let's just say we have something like 12x squared plus 20x plus 7, and that's 0. Y 0 equals this, right? I'm not going to try to factor this, not in the slightest. I'm not even going to begin to factor this. I am going to take all of these numbers and plug them in to our quadratic equation. That will be a lot faster. So I highly recommend, you want to know your quadratic equation because it will always work, okay? So your quadratic will always work. Factoring, sometimes you can't factor things. Sometimes it's not possible to factor things. And so you get stuck and you'll get jammed up, right? I went a long time without knowing how to use the quadratic formula, a lot longer than what I am willing to admit. But once you get comfortable with it, it's preferred. It's the preferred method, really, in my opinion, right? It can be very nice because instead of wasting time trying to factor this crazy looking thing, which I can't, it will take me way too long, and most likely that this one you probably won't be able to factor. So I highly recommend you you use the quadratic formula, right? So we could solve this right now. Like, let's just do that. So our A in this one is 12. Our B equals 20. And our C equals 7. Okay? And we want to plug this all in, so we have to, and this is going to look a little bit ugly, okay? I'll change the colors. So we have our negative 20 plus or minus the square root of 20 squared, and this is where your calculators can really, really come in handy, right? Minus 4, and then A is 12, and then C is, where is my C? It's 7. And all of this over here is above 2 times 12. Okay? So this is, it's gonna be ugly export. It is, but don't worry too much. Okay, so we are doing 20 times 20. So what is 20 times 20? It is 400, right? If I remember correctly. Boop, 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 boop. Yeah, that sounds about right. Yeah. My brain is not functioning on the highest level today, so. Yeah, of course, holy moly. Yeah, it's one of those mornings. I was a little bit late to streaming. I had my mic muted for the first, I don't know, few minutes. So we have I always like to kind of separate things out. So I have my negative 20 outside, right? We don't need to write this. All I'm going to focus on right now is underneath this square root, because that's going to be where the most challenging stuff is going to happen. So we have 400 minus, and then what's 4 times 12? That's 48. And then what is 48 times 7? It's 280 plus 7 times 8 is, what is that? 56. So we have, oh, I lost it. 48, oh my goodness. Ugh, my brain. So 3 times 12 times 7. Let's pull out our calculator. You don't have to do everything in your head. 4 times 12. Usually I can do it all in my head though, so that's how I can tell I'm tired. I didn't get very good sleep last night. Woke up at 1 a.m. for absolutely no reason, and it sucked a lot. So 336. 336, and then all of that is over our 2 times our 12, which 2 times 12 is 24. But what is 400 minus 336? It looks like that is 64. Oh my gosh. So we have negative 20 plus or minus. So then negative 20 plus or minus. So 400 minus 336. What is that? That does end up being 64, the square root of 64, all over 24. I can't believe we're actually going to get a non-crazy looking answer. Okay. So, oh, sorry, this is all x equals. X, because we're finding the zeros. We're finding when y equals 0, right? So, then, what is the square root of 64? It is negative 20, and then plus or minus, it is 8. All over 24. What is negative 20 plus 8? That would be positive, or negative 12, right? So our two answers are going to be negative 12 over 24. We'll say x1 equals that. And then negative 20 minus 8, x2 will be 28, so negative 28 all over 24. And then that can reduce down, what can that reduce down into? Let's see, so 2 will go into it. 3, nope, nope. So let's just cut it all in half. So we're at 14 over 12. You know what? We can make this a little bit easier. Let's just write this as a mixed number. So we have x squared equals, how many times does 24 go into a negative 28? One whole time. So we get a negative 1, and our remainder is 4 over 24, and that would be 1 over 6. Negative 1 and 1/6. So these are our two zeros. So we have x1 equaling negative 1/2, and x2 equaling negative 1 and 1/6. So I just converted that over to a mixed number. So that's just one that I made up. I'm actually still happy that we did that, and that took a few minutes, right? That's why you want to have that quadratic. I'm still an advocate for having it hammered into your head. It will help you out because you don't want to factor that one. That one is just gross. That one looks nasty. It looks not fun. So I would say I would highly recommend get comfortable with factoring, because when you can use it, it will be fast. But also get comfortable with using your quadratic equation. Between those two things, you might have 4 problems on your GED test that have to do with factoring and quadratics, possibly more, but we'll see. So it'll always, like, so I'll say, from what I've seen on like practice tests and stuff with the math practice test, they like to answer things, they like to leave it kind of in this form sometimes, where it has the plus or minus. My preference, like if you were sitting in my classroom, I would tell you to split it up, right? Because what we were able to do once we split it up is we were able to kind of simplify and reduce the fractions, and like, hey, look, it is at negative 1/2. I could graph that negative 1/2. It might be a little bit harder to graph the negative 1 and 1/6, but we can start to graph it. So that's why I will still recommend splitting it up. And if you remember, so what does this represent? What does all of this represent? It represents where it crosses the x-axis, right? This represents the 2 points where it crosses the x-axis. Ooh. Excuse me. So it does come in handy. It is pretty nice. Quadratic formula it's a beast of a formula. I'm not going to do this on stream, and I definitely can't do it this morning. But you know how, I think it was yesterday, export, or the day before, we had somebody come in and talk about they called it the hypotenuse formula, right? But you know, it's that Pythagorean's theorem. That is actually, there we go. Oh, too far. So that quadratic formula kind of comes from Pythagorean's theorem a little bit. You can do some fancy, crazy math to Pythagorean's theorem and end up getting the quadratic. It stinks, but ow. There we go. Okay. Let's do another problem where we're just gonna factor it, because it'll be nice practicing that skill. Uh-oh. If this keeps up, I might have to call it good a little bit early today, because this is, my allergies are going crazy. I guess I'm gonna just sneeze on YouTube steadily. Oofda. Okay, so where are we? Where did my example sheet go? There it is. Okay, we are good to rock and roll. So so this is something you'll see too, right? I want to give you a nice little demonstration of this. So we get, this is our equation that they give us, and they say to solve for y equals 0. Okay, something like that, right? Or they ask you to find where the quadratic crosses the x-axis, something with those types of words. But they give us this problem where it's and they like to, okay, my pet peeve with the GED, my pet peeve with any of your high school algebra classes now, all of I'll even admit it, it's the Common Core education system, which my upbringing wasn't any better. I had the No Child Left Behind, right? But they use all of these different, they use like W, and they use N. I've seen C a lot. They like to use these crazy letters for their equations, and it's really annoying. Super, super annoying to me. But I will stick to it just to throw everybody off. We have W squared plus 7W minus, and I think the reason why they do this, 21, is so you get comfortable with that idea of it being a variable, right? Oh my gosh. Yeah, we like yeah, when we let me get a little bit more warmed up on my more complex math, and we will change the Pythagorean theorem into the quadratic equation. You won't, I don't know, you might get sick of it and be like, you know what, I'm gonna peace out from the stream a little bit, I'm gonna put you on mute, Paul, and that'll be it, because you'll watch my brain operate at pretty high levels on that day. Definitely cannot, like, I will crash and burn if I try it today. So 23. I mean, there's some high level math that I could just throw at you and you'll get really fast. Even the concepts of calculus, right? Like calculus, if you don't know, Isaac Newton invented it, or not. There's some math drama there too. I'm taking a slight detour in a math story time. Okay, so calculus wasn't. Technically, people argue, like, was calculus invented? And Isaac Newton, we all know of Isaac Newton, the apple falling on his head and gravity, Isaac Newton's idea of gravity. But to put it bluntly, Isaac Newton was just a horrible human being. He was not a kind human at all. Incredibly kind of messed up in the head, which, I mean, he was a super genius, so it makes sense. But he discovered calculus and he wrote out his methods of doing that field of math. And at the same time, another mathematician had created or had discovered calculus. Actually, two other mathematicians had discovered calculus. And they all kind of came out at the same time, or roughly the same time. But Isaac Newton, like, destroyed the other two people. In fact, Isaac Newton, basically, he was trying to get one of the other math guys to basically, like, well, disappear himself. He really was upset because he's like, oh, this guy just stole all of my work. But in reality, they both kind of figured things out around the same time period, and Isaac Newton was just being a horrible human being. And the funny thing is when you get into calculus, most of the notation and most of the stuff that you use is the other guy's stuff. You don't use Isaac Newton's notation in calculus, so it's pretty neat. Okay, so let's do this, and we will figure this out. So how do we do this? So what we need to do, we need to set this equal to 0, right? So usually our y is right there, right? What we will do is we'll set this to 0. So how do we get to the 23 into a 0? We subtract 23 from this side, and then we subtract 23 from the other side, and then we rewrite our equation. So then we get w squared plus 7w minus, and then minus 21 minus 23 is a minus 44, and that equals 0. Okay, so we're good. Oh, okay, good. Yeah, we can play around with some Pythagorean theorem things too. That's a good thing to practice. I would say there's a good chance you'll get one question on the GED with Pythagorean theorem. but it's not too bad. Once you get it down, you'll be golden. You'll be right as rain. You'll be ready to rock and roll. We'll do this, and then we'll throw in just a random Pythagorean's theorem type of thing. Okay. I've listened to myself so much that when I make that noise, that like higher, like it moves from lower pitch to higher pitch, like I'm like, that is so annoying. Incredibly annoying. I've listened to myself way too much over the last few weeks with all of my videos I've been making. It's nuts. Okay. So we split this trinomial up into a binomial. It still equals 0. Our W is in front, and the nice part is we don't have to do any crazy guesswork with it. So then I ask myself the factors of 44. So what are the factors of 44? And it's a negative 44. So let's just start working through it. So we have a negative 44 and 1. And I always like to, when I'm doing numbers like this, I always like to start off here with our 1, and then we'll work our way up, okay? And then we have our, I'm trying to write this where it's not horribly all over the place. And then we will get the negative 1 and 44. And then we will have 2 and negative 22. 2 and negative 2 and positive 22. And then 3, does 3 go into 44? So let's think here. I don't think it does. Nope. 4, 8, 12, 5, 10, 15, 16. Nope. 4 does not go in. 5 does not go in. There has to be one more. There has to be another one. Let's take a look. And if you know the answer, don't be afraid to blurt it out. Oh, yeah. So 2, I skipped a number. 2, 3 doesn't. 4 does. 4 does. Yeah. So 4 times what? So 4 times what? That is a negative 11 is our factor. And then our last one here will be negative 4 and 11. Now that we have done our factors of negative 44, go ahead and you find the one that when you add them together, it equals a positive 7. And I definitely won't wait for that to come up. I will just go ahead and give you that. It is, so we want a positive 7. So it's that last one. That one right here is our key to success. And I'll move this right up here. And we will erase the rest of this because that is super messy. Oh. Okay. That's small. Okay. So then you just plug and play, right? You put our you can put your negative 4. It's too small. Negative 4 and a positive 11. Those are our two binomials for this problem. Set each one equal to 0. And W plus 11 equals 0. Add the 4 over, minus the 11 over, and we get W equals 4, and W equals negative 11. So those are the points. And you might be like, so like the other problem why I have issues with them using random letters like this is because when you use like X, which normally under normal conditions your W would be an X, it makes it a little bit more understandable to graph, right? So this is W, or this is X, our second X answer. That's negative 11. So you're crossing the X axis, so your ordered pair will be 4 and 0. and your other ordered pair will be -11 and 0. And there you go. You're good to go. You're good to go. Easy peasy lemon squeezy. That's all it is. Plug and chug. Nothing too nuts. So, let's take a look at some Pythagorean theorem stuff. And then after we do Pythagorean theorem, we will call it good. So, where is my webpage? Math aids. We're going back to math aids. I'm going to just pull up some examples from math aids with the Pythagorean theorem in it. You know, really funny, interesting fact there. Pythagoras really didn't do anything. He just put his name on it. This had been in existence before he came around. And when, he put his name on it, it was kind of entered into the Great Library. And then the Great Library was burned to the ground. And one of the few things that survived was Pythagorean's theorem. And so he gets all of the credit, even though he didn't do any of the work, really. This knowledge has been around for a long time, that type of thing. Let's see. Ooh, definition worksheets? That sounds interesting, but we won't get into that. Oh, the distance formula? That's another one that we might want to know. Oh, this is actually really useful. It's super nice. Okay. They don't have any examples, but... Oh, actually they do. So we have, let me erase everything. I'll add a new layer. And we will move on to our Pythagorean theorem. We'll use a cool green. So we have our triangle. Okay, we have our triangle. And our side over here has a 5. And this side down here is a 7. And this is our C. The other way of thinking of this, right, is we have our A side, so I'm going to put this kind of in like a parentheses. So this is A, this is B, and then this is C. Okay. And okay, got that. Got it all set up. So then we have our Pythagorean theorem, which is A squared plus B squared equals C squared. Okay. And then, what is A? A is 7, so we're going to square that, plus our B is 5, so we're going to square that, and it equals C squared. Okay? All you need to do, 7 squared, what is 7 times 7? So this is 7 times 7, plus 5 times 5, equals C squared. I'm going to keep that still as C squared. 7 times 7 is 49, plus 5 times 5 is 25, equals C squared. And then 49 plus 25, that will be, well, we have 54 plus 20 is 74, and that equals C squared. And then we have to do the square root of both sides to get rid of our C squared. That cancels out the C squared, and what we're left with is C equals the square root of 74. Okay, so not too crazy yet. Okay, just double checking my chat again. So square root of 74, what is the square root of 74? So it's 32 times 2. Let's see what other factors of 74 are there. 3, does 3 go into it? Nope. 4 does not. 5 does not. Is it just 2 and 32? No, it can't be. There has to be another number. Oh, like 16 and what? What times? Hang on. Oh, it doesn't. 74 divided by 2. Oh, it's not 32. 74 divided by 2 is 37. So, we could probably just leave this as is. 74, I don't think there's anything else that goes into it other than 2. We can double check. Always be a plus? Yeah, a squared plus b squared equals c squared. That is your Pythagorean theorem. The only time that it, like, and even at that, it will just always be a plus. Always, always. Because, like, right for a second there, I'm like, well, what if your b is negative? But you have to do your exponents first, right? And plus, you're dealing with lengths of a triangle, so you won't have any negative numbers ever, really. They might give you negative numbers if they want to be weird, but it should still be a squared plus b squared equals c squared. Pythagorean theorem. Let's see. Factors of 74. Yes, just 2 and 37. And so that means that we're done. We're done. Square root of 74, we can leave it as that. That is our answer. And when you put that into the calculator, what is the square root of 74? What times what equals 74? It's going to be somewhere, it's like 8.8, I think. No, 8.7. The square root of 74 should be like 8.7. Let's see how close I am. The square root of 74. It's 8.6. Dang it. I was off by 100th. So the Pythagorean's theorem, it's not going to be bad export when you take your test. It's plug and chug. You put your, here, hang on. Let's change this up a little bit though. I'm going to erase our numbers. Oh, I'm going to cover up our numbers. Oh. Okay. And instead of giving us all of the nice stuff there, the 2 legs of our triangle, you will run into this. So let me think of some numbers to put in. Okay. Oops. So our side 1 will be 21. And this is 35. Okay? And they want to know what this is. They say, hey, solve for A. Okay? So you have to figure this out. Oh. That's gross. Hang on. No, we're good. We're good. It's just, it'll look weird for a second. So, what we'll plug these things in. So we know that a squared is 21, and then plus b squared equals c squared, and that's 35. And so how do we go about doing this? You just solve for your b. So subtract the 21 over. You get b squared equals, what's 35 minus 21? That is 14. Something doesn't seem quite right with this. We'll see. And then the square root of that and the square root of that. So it's just the square root of 17. Or 14, sorry. I feel like something didn't get added up right. But you get the idea. You have to do it backwards, right? you kind of have to do the whole thing a little bit backwards. I hope I didn't confuse you. Is it 40? 3, 4, 5. I feel like something isn't right with this problem when I look at it. I did some magic math. Oh. Hang on. What did I do wrong? So, this 21 is just A. Or not A, it's like our sorry, that's I wrote everything wrong there. But so let me rewrite that instead of saying B squared. So our A is what's unknown plus, and then 21 equals, so what is our 21? That is just side B, right? So we have to square that, and that equals 35, and then this equals 35 squared, right? So how do we go about doing this? We have to do our squaring. So 21 times 21, A squared plus 441 equals 35 times 35, 1225. I think I'm still on the screen. I am. And then you subtract over. Let's do a different color because purple is a little bit hard to see. Subtract over your 441. 441. Oops. And what do we get? We get A squared equals, so minus 441, 784. And then you take the square root of that. Good. So how you get rid of your exponent? Sorry, I'm skipping steps. I'm not skipping steps, but I'm not explaining it thoroughly. You take your square root. That cancels out. And then A equals the square root of 784. And you just do that in your calculator. And that is 28. So A equals 28. So this side here is 28. And we are good to go. So I'm really happy I caught it. I'm really happy that I caught my mistake earlier. So what I did is I recognized that our B of 21, B equals 21, but we still have to square it. We have to square that B. And then we have to square that other side. We have to take 35 squared, right? And that should give you the answer. But what day is it today? It is Thursday. So tomorrow, yeah, 28. Nice and clean 28. Do you know why? Do you know how I knew it was going to be a clean answer? Why I knew I was wrong? Because this is actually, this triangle here is actually the 3, 4, 5 triangle. So if you gave a construction worker this triangle here, and you said, hey, Johnny, we have one wall length of 21 feet and the other wall length of 28 feet. How long is the wall in between? They'll be able to answer that question pretty fast. They'll be like, oh, it's 35 feet, Paul. And the reason why is because it's a 3, 4, 5 triangle. So it's just, all it is this triangle scaled up. So it's okay. So this is times 7. This is times 7, and this is times 7. So that's another thing to look for, a little cheat or a hack for any of your Pythagorean stuff if you get on the test. If your two sides are this triangle, the other one will be the other type, right? Like, so it will still reduce down to a 4 or a 3 or a 5. A way to really fast, if they show you a triangle and you're like, hey, this first number over here on the left is divisible by 3 by, I don't know, 6 times. So if it was 18, And then this number here is also divisible by 6, so that would be what is 24. And then this one would be 30. So you can just read it, right? Yeah, I don't know. We'll see if I get any rest, but I hope you have a good day as well. Tomorrow will be another free-for-all type of day. I think what I'll do is I'll go through a unit review on the GED test, right? Like, so an entire unit of math, and we'll just hang out and hammer those out. But I hope you guys have a wonderful day. I appreciate you, and I'll talk to you guys later. Have a good one. Definitely appreciate you, Export. You have an excellent day. Like, comment, and subscribe. Take it easy.